So we have 2x squared over x squared. The coefficient on top is 2. The coefficient on bottom is 1. So when we divide coefficients, we get 2 over 1, which is 2. So this is just a one-step problem. You really don't need to show much work at all for this. You just look at the problem you're given, look at the highest powers, look at your, remember your acronym, Bobobot needs DC, figure out which one it is. In this case, they're the same, so we just divide the coefficients and we get 2. And that's your answer. So same as before, you write it out as the limit as x goes to minus infinity of the fraction equals 2. And this is your boxed answer. All right. Oh, I have a question here. Do pair answers minus 1/4, or do we add the limit? Oh yeah, so for all of these, you want to write your answer with this limit part in front. Because that's the question that it's asking. It's asking, what is the limit of this thing? So at the end of your work, don't just write 1/4. Write the limit of this equals 1/4. Are those rules the same for positive infinity? Yes. So yeah, these are the same rules for positive or negative infinity. So nothing to worry about there. This behaves the same whether it's a plus or a minus. Bobobot eats DC. It's that simple because it's only the highest power. So for infinity, we only care about the highest powers. So you can just ignore the 7x plus 3. You can ignore the minus x minus 12. Just look at the highest powers, and the problem is very simple. Okay, so are there any questions on part C before I move on? All right, cool. I can work an example later if y'all want. So that's number 1. That's one of the longest ones because there's 3 parts to it, A, B, and C. They're almost like full questions within themselves. Okay, we're moving on to this is the limit definition of the derivative. So there are 4 steps here. The limit definition of a derivative. So what we're trying to do, we're trying to find the derivative of a function in a very specific way. So we're trying to use this formula to find the derivative. So it's the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay, so that's just the formula. I'm not sure if you'll be given that formula. I can ask later. But yeah, this is the formula. So you're just going to plug into this. Step 2 is to simplify with the ultimate goal of canceling the h on the bottom. Because if we try and plug in right now as it is, we'll have a 0 on the bottom. So h goes to 0, would plug in a 0 on the bottom, and that might not be a nice number. So we plug in, simplify, cancel the h on the bottom, and then the last step is plug in. So now we put h equals 0. So this is the same process as 1a and 1b. It's that same chart. All right, so yeah, you probably won't be given any formulas, but I think this is just one of 2 formulas that you're going to need to know. So commit this to memory. The limit definition, f of x plus h minus f of x over. Okay, so for number 2, we are given this function. Use the limit definition of the derivative to find f prime of x if f squared plus 4x minus 7. Okay, so first thing I did here is I wrote down what f of x plus h is because we're going to need that. So all you need to do to get x plus h, f of x plus h, is just put in x plus h wherever there's an x. So x squared becomes x plus h squared. 4x becomes 4x plus h, and then minus 7. All right, so that's all you need to get f of x plus h. And then we have everything we need for our formula. So the limit definition formula is this. The limit as h goes to 0 of f of x plus h, which I already wrote, minus f of x, which we have, all over h. Okay, So now we do some simplification. We're trying to cancel bottom because we can't plug in right now. We can't plug in a 0 because we'll end up dividing by 0. So we're going to do some simplification. And the way you do it for this problem is you expand and combine. Okay, so if I have x plus h squared, I'm going to FOIL that out into x squared plus 2xh plus h squared. Okay, so you're just going to go through every term and expand it. So the 4 plus h, that will be 4x plus 4h. So I'm just getting rid of all the parentheses, basically. All right. And then what I've done on this last part is I've distributed minus sign. So remember to do this or your answer will be off. So we have minus x squared minus 4x plus 7. So it's minus all this stuff in parentheses. So you take the minus and you put it on everything inside. Okay. Once everything's expanded like this, then we combine like terms. So we look for things to cancel. We want to cancel things. Just for example, we have x squared here, and we have minus x squared. So those cancel, those go away. Also, we have 4x and a minus 4x. Those will cancel. We have a 7, we have a minus, those will cancel. And so once I've done all my, this is what we're left with. 2xh plus h squared plus 4h all over h. And now you can cancel the h on bottom. So that's our goal, to cancel the h on bottom. So we divide every term by h. Everything has an h in it. So we divide every term by h, and we get 2x plus h plus 4. And then the bottom now is just 1, like the h goes away. Okay, and now you have no issues. Now we can plug in h equals 0 without any problems. So if I just stick in a 0 here, we get f prime of x equals 2x plus 4. Okay, so the whole objective of all this work was to cancel the h on the bottom and then plug in. So that's it, just simply stated. Okay, let me check my questions real quick. On the last one, if the top was bigger, would the answer be does not exist? Yes. Yeah, so that's big on top, none. So let's see. I think she said we're not being given any formulas. Oh yeah, you're not being given any formulas. And so has she mentioned if it's open note? Does anyone know that? I don't.
She hasn't said anything.
So.
I don't think so.
Yeah, I don't think these are. I think these are open note. Like if she doesn't give you a formula sheet, she probably doesn't a lot of notes either. But I can send out an announcement if I hear different. But for now, just assume that you're not given notes, right? And I'll tell you otherwise if you're allowed to have them.
I have a question really quickly. Do we have to, for this question on the exam, do we have to do that first part where we put in the x plus h? Or can we just like get straight to it?
Okay, yeah, good question. So yeah, for all of these, I've done a ton of work just to explain every step. But if you know what you're doing, you can skip whatever parts you need and get to the answer. So this was just for my sake and yours. Same with most of these steps. Certain key steps you do want to show. Like for this one, the big step is plugging into your formula. And then as long as you get from there to this final answer, you're good. Okay, so the work I've showed is more than necessary for a lot of these. So yeah.
Can the cancel the h on the bottom just be limit 2x plus h plus 4 and just leave the 1 out?
Yeah, so yeah, those mean exactly the same thing. So dividing anything by 1, you can just forget that the 1 is there. It's the same as writing like 1x. 1x is the same as x. So yeah, they're identical.
And for that problem, do we need to write the limit as h approaches 0, or can we just write what's in the box?
We can just write what's in the box right now, because in the previous problems, we were asking, what is the limit? So your answer is the limit is minus 1/4 or whatever. In this case, it says, what is the derivative? So we want to, so our answer is the derivative, f prime of x, is 2x plus 4. So the form of your answer should match the question that's being asked.
Okay, thank you.
You got it. Okay, so any questions on number 2? Any more questions? I can do another example later if you want. Okay, number 3. Number 3 is 3 parts, but they're all very simple. So we're given this function f of x equals 3x minus 2 over x squared minus 2x minus 15. So we have a fraction, just like we were given in the last two problem, or sorry, in problem 1. We're given this fraction with a polynomial on top and bottom. Okay, part A asks, what are the points of discontinuity? And this is a very easy question to answer. There's just one thing you have to know. Where is the denominator equal to 0? Right? Because when the denominator equals 0, that means we are dividing by 0. Right? And that's a point of discontinuity when we're dividing by 0. So all we have to do is take the denominator, which is x squared minus 2x minus 15, and set it equal to 0. So what I've done is I wrote it here. This is the denominator. I factored it. So this factors into x plus 3 and x minus 5, whatever method you choose. And I set that equal to 0. And now, as you might remember, the way you get this is you just take the negative of these numbers. So this term x plus 3 gives us x equals minus 3, right? So when x is minus 3, you have minus 3 plus 3 is 0, right? And then x equals 5 will make this term 0. So those are your two options. X equals minus 3 and x equals 5. Those are the x values of the points of discontinuity, which is what it's asking for. Okay, any questions on that one? It's just a one step. Anyone clarification? Okay, cool. So this one leads straight into part B. So what we do for part B, vertical asymptotes, is we're going to look at these discontinuity that we just found. Oh yeah, first, yeah, let me explain how I factored this. So yeah, someone asked how I factored it. You can use the quadratic formula here if you don't want to factor it. Quadratic to you. But the way I do it is I look at this. So we have x squared minus 2x minus 15. What I do is I look at the factors of 15. Right? So the factors of 15 are, say I had like, let's look at 3 and 5. So what I'm thinking when I do this is I think, okay, 15 equals 3 times 5. There are other factors, but these work. So if I'm trying to make 15, I need either minus 3 times 5 or 3 times minus 5, right? And so this is all just based on foiling. So when I multiply these last terms together, I get this. So I need them to be either minus 3 and 5 or 3 and minus 5. And then they need to add to this. So whatever numbers I pick have to multiply to minus 15 and have to add to minus 2. So if I want them to add to minus 2, this is what I need. Okay. So 3 and minus 5 gives me a minus 2. And so I know that my terms are x plus 3 and x minus 5. So that's kind of a convoluted way to do it, but that's the way that I've done it. You can use any other method. Quadratic formula is usually, it's a general way. You don't have to do any special thinking. Okay, part B. So vertical asymptotes, we look at these points of discontinuity that we just found. So x equals -3 and x equals 5. And we take the limit at these points. If the limit does not exist, so if we're dividing by 0, then it is a vertical asymptote. Okay. One thing that can occur, so what I've done in this line of work is I just did the same thing we did in question 1, right? So I take our limit, I plugged in, and I see what we got. Now it's possible to get something like maybe like 11/8. So that's just a nice number. It does exist, and what that means is there's not a point of discontinuity, or there's not a vertical asymptote for that point. Okay, there's only a vertical asymptote if the limit does not exist at this point. Okay, so that's what you have to remember. That's why we're doing this work. That's why we have this work. So I just did the same stuff we did in part A, plugged in our values and see what we get. So at x equals -3, limit does not exist. At x equals 5, limit does not exist. And so both are vertical asymptotes. And I write it like this. The vertical asymptotes are x equals -3 and x equals 5. Okay, so all we do, we just check the points of discontinuity. Okay, any questions on part B? So just take the limits at those points. Oh yeah, I can leave that here. Okay, yeah, I can also send this out to you later if you want to look at it. Okay, so part C, same fraction, but this time we're going to infinity. All right. So to find horizontal asymptotes, all you do is you take the limit at infinity. So you look at the limit as it goes way out to either side, essentially. And if you'll remember, for problems that look like this, our acronym works the same for either one. So Bobo, Bot, and Eats DC, it's the same whether you go to plus or minus infinity. So usually you're supposed to in either direction, but for this problem, it's going to be the same either way. So you can just write it as plus infinity. Okay, so asymptotes, those are long-term behavior at infinity. So we're going to do our Bobo bottom, look at the biggest powers. On top, it's x. On bottom, it's x squared. So that's big on bottom 0. So our limit is 0. And that gives us our horizontal asymptote, y equals 0. Now, we write it as y equals 0 because y is a height. Like if you imagine the plane, the axes, y is your height. So we're looking at everywhere where the height is 0, y equals 0. That gives us a horizontal line. Okay. All right, so part C is just one step. Any questions on this? So yeah, just like before, we have limits at finite numbers and we have limits at infinity, and there are different ways of handling each of those. Okay. Let's keep going on. Number 4.
Wait, can you go back for 1 second?
Oh, sure. Let me get ahead of it.
Yeah, I'm good.
All right, cool. Okay, number 4. This is the proof one. Okay, so we want to use a definition to determine whether f of x is continuous. Okay, so let me just read the problem. Use the definition of continuity at a point. Determine whether f of x is continuous at x equals 0. So they give us this point x equals 0 and ask us, is it continuous there? So this is the definition that you need to know. If the limit exists at that point, and it's the same as the function value, then f of x is continuous. Okay, so we've done a lot of limit work. So if the limit exists and if you plug in x equals 0, that gives you the function value. If those are the same, then the function is continuous there. Okay, so I have a little roadmap here of the work that you need to show. Okay, so let's say we're trying to determine whether it's continuous at this point C, right? So maybe it's like in this case, it's 0. So we want to know if it's continuous. We take the left limit, which you know how to do. We take the right limit, which you know how to do. And if they are equal, then the limit exists. Okay. Then you take the function value. All that means is that you plug in your number into f and see what you get. And if that is the same as the limit, if the function value is the same as the limit, then f of x is continuous. All right. And so big picture here, you want everything to be equal. If everything's equal, it's continuous. So if the left limit, the right limit, the limit, and the function value, those are all the same thing, then then it's continuous. That's all there is to it. But you have to find all those things. Okay. So for this problem, we are given this function. This is called a piecewise function. So essentially you have two different cases. For x values less than 0, this is the function we use, minus x plus 1. For x values greater than 0, we use 2x plus 1. Okay, so those are our two options. You know, the first one, less than or equal to. The second one is greater than. It's important to notice which one is on. So the equal sign is on the first one. That means if I plug in x equals 0, if I plug in exactly 0, then I use the top one. And that's what that equality means. Okay. Step 1 from our chart. I want to find the left and right limits and make sure they're the same. Okay. So to find the left limit, we look at values less than 0. Left limit less than. Just remember that. So this will give us the left limit, minus x plus 1. So we're going to take the limit of this as it approaches 0. All we do for that, we know what to do. We just plug in. So we plug in x equals 0 and we get 1. Pretty straightforward. So that's the left limit. For the right limit greater than. Right limit is greater than. So we look at the values greater than x equals 0, which is this one, this function, 2x plus 1. So we take the limit of 2x plus 1 as x goes to 0, and plug in a 0, we get 1. So good, we got the left and right limit. They're the same. And so the limit is also 1. Limit exists, and it is also 1. Okay. Last step is find the function value. So that just means plug in a 0 into f. Okay. So if we look up here, we plug in a 0. We use this first one for x equals 0. So we're going to plug in a 0 into minus x plus 1, which gives us 1. And everything's the same. 1, 1, 1, 1. The left limit, right limit, the limit, and the function value, they're all the same. And so this is our answer. The function is continuous at the point. So this is one of the problems where she wants you to write it out as a sentence, explaining exactly what's happening. So there are two ways to write it. You can say the limit exists and is the same as the function value. So f of x is continuous at x equals 0. Okay. And then there's a shorter way to write it, which is to write the limit of f of x as it goes to 0 equals the function value at 0 equals 1. So f of x is continuous at x equals 0. You just need to get the definition in there. It has two parts. The limit has to exist and it has to equal the function value. And if both of those are true, then it's continuous at the point. Okay, so this phrasing is very important or you'll lose points. Okay, so you have a question. Why do you use the top equation for finding the function value? Right, that is because this is a piecewise function. So depending on what x is, we're going to use either the top function or the bottom function. Now the top one says if x is less than or equal to 0. So the equal to is the important part here. If I have x equals 0, I'm going to use the top function. And that's why I'm using minus x plus 1 for this one. Okay, any questions on 4? This was a pretty long one. All right, I can work another example later if y'all want. All right, number 5, 6, and 7. These are quick. These are all the same idea. It's just use the power rule. And there are 2 main steps here. So you're going to be given a function f. Step 1 is to rewrite it so it looks nice in a specific form. Step 2 is to use the power rule on each term. So rewrite and use the power rule. That's all there is to it. So problem 5, we're given f of x equals minus x cubed over 5 minus 5 over 4th root of x cubed plus 7 over x to the 5th. Okay, and so our first step is to rewrite it. We want everything to look like this. Ax to some power. So we want a constant times x to some power. And you'll be able to tell what this form is supposed to look like as we keep going. But to rewrite it, there are 2 things that you need to know. X on the bottom, that means we have a negative power. And roots give us fractional powers. So like a square root, that's a 1/2 power. A cube root is a 1/3 power, and so on. So let's look at this. So this is what we're given. So if we rewrite every term, the first term, we have minus x cubed over 5. That stays the same. It's already in the right form. The second term, we have minus 5 over 4th root of 3, 4th root of x cubed. So the 4th root of x cubed gives us a 3/4 power. And then the fact that it's on the bottom makes it negative. All right, and I can explain that more later if you want. That's kind of confusing part. But the roots make it a fractional value, and the fact that it's on bottom makes it negative. All right, and then for the last term, we have 7 over x to the 5th. The x to the 5th is on bottom, so that's a negative power. So 7 over x to the 5th is the same as 7x to the minus 5. Okay. Okay, and that's it. We've rewritten it in the right form. Some number times x to a power. That's what we want them all to look like. Reason being, now we can use the power rule very easily. So there are 2 steps to the power rule. First one, look at the exponent. You're going to multiply by that exponent, and then you're going to drop the exponent by 1. Okay, so for this first term, we have x cubed. So we're going to multiply by the exponent, that's 3, and then we're going to drop the power by 1. So it'll be an x squared. So x cubed becomes 3x squared. Okay, that's the rule. That's the pattern. And then we leave this constant just out in front, multiplying by it. Okay, so in our second term, we have x to the minus 3/4. So what do? We multiply by that power, minus 3/4 x to the minus 7/4. Okay, so I took the power and I subtracted 1. So 3/4 minus 1, that's the same as 3/4 minus, that's minus 3/4 minus 4/4. So that's minus 7/4. So we'd subtract 1. And then the last term, x to the minus 5, we multiply by the minus 5. And then we drop the power by 1. So we get x to the minus 6. Okay, so I rewrote all the terms, and then I took the power rule on each one of them. And that's what we're going to do for 5, 6, and 7. Okay, Last step is just simplifying here. So minus a fifth times 3, that's just minus 3/5. Minus 5 times minus 3/4, 15/4. And 7 times minus 5 is minus 35. If you know what you're doing, you can go straight from this to the answer. You don't have to write out this step inside. Okay, and then I have some explanation here about how these work. So the middle term for this one was kind of ugly. So we had 5 to the, we had 5 over 4th root of x cubed. So there are really 2 steps you can do here. 4th root of x cubed, that gives us a fractional power. That 3 stays on top, and then the 4th root, the 4 goes on bottom. So 4th root of x cubed is x to the 3/4. I'll go up in a second, yeah. And then the fact that it's on the bottom means that it's a negative power. So x to the 3/4 on bottom is the same as x to the minus 3/4 on top. Okay, and so that's a breakdown for one of them. So roots are fractional and things on the bottom are negative. All right.
But you can leave it as 15 over 4x, right?
I can leave it as 15 over 4x. Oh, yes.
4x
Yeah,
raised,
you can. You could also, you can put it back into this sort of form with like radical.
Yeah, but we don't have to.
But yeah, you don't have to. They're equivalent.
Yeah,
So as long as the answers are the same, as long as they mean the same thing, you'll be correct. Yeah. Okay, it says, how did I get minus 1 over 5x3? Oh, so all I did, if we look at this first term, we have this minus x cubed over 5. So that's the same as minus 1/5 times x cubed. So all I've done is I've brought the fraction out front so that we can see it. Can I be your teacher? Well, I am for today and for like the next 3 exams. Okay, so this is how you do it. Any other questions on number 5? I can go back later. 5, 6, and 7 all look the same, so just wait for the other ones. They should be helpful. Okay, so let's keep going. All right. So number 6. Remember our 2 steps. First one is rewrite it in the right form. Second rule is use the power rule on each term. Rewrite it and then use the power rule. So for number 6, Miss Seats actually had a mistake on her key for this. So if you're having trouble matching what she got, it's because she had a mistake. So the function we're given is x squared plus 6 all squared. So x squared plus 6 all squared. We're going to rewrite it. So we know what to do in this case. So we have x squared plus 6 squared. So that just means x squared plus 6 multiplied by x squared plus 6. And you know what to do in this situation. You FOIL it out. So first, outer, inner, last. I'll answer that question in just a second. So we have something squared. Write it out like this. So x squared plus 6 times itself. We're going to FOIL it out. So first terms, x squared times x squared gives us x fourth. The inner terms is 6x squared. The outer terms is 6x squared. So we get 12x squared. And then the terms are 6 times 6 is 36. Okay, so that's just foiling. And as a result, we don't have parentheses anymore. We have everything in the right form. So we have x to a power, we have 12x to a power, and then we have a constant. Okay, so it's in the right form now. All we do is take the power rule. So looking at the first term, we have x to the 4th. So we take the 4, multiply by 4, and then drop the power by 1. So x to the 4th becomes 4x to the 3rd. Okay. Second term, 12x squared. Multiply by the 2 and then drop the power by 1. So x squared becomes 2x, or 2x to the 1. I just written it that way. And then the last note is that the derivative of a constant, so in this case, it's just 36. There's no x's at all. The derivative of a constant is 0. So that just goes away. Okay, so we rewrote it. We took the power rule of each term. And if you simplify that, you get 4x cubed plus 24x. And that's your answer. So,
On the thing, are we supposed to like take out another 4x, or do we just leave the answer like that?
are we supposed to take out another 4x?
Like, do we have to simplify it further, or is that good?
You mean like, no, they're equivalent. So you're saying this, right? So 4 times, like you could pull things out, like it could be 4x times x squared plus 6, right? And so these are the same thing. But no, just leaving it like this is totally fine, as long as they're the same answer.
Okay, thank you.
You got it. Now this form is actually what you'll see when you learn how to take the chain rule. So that's coming later. If you'll notice, there's an x squared plus 6 here. Well, there's an x squared plus 6 here as well. And so this is actually a much faster way to get the answer, but you can't use it yet. So just leave it like that. You can simplify it if you want, if you have time, but you only have an hour, 25 minutes. So try and save as much time as you can. Okay, any questions on 6?
Say that again, you said an hour 25?
Sorry, hour, it's just your normal class time.
Wait, perfect, thank you.
75 minutes, so hour 15, I think.
I think she told us that we only get 50 minutes, but I don't know if that's wrong because I feel like that's really a short time to take this test.
Mhm.
She said we're supposed to have access to it at like 10 minutes before the class, though. I think at like 9:20.
Okay, so I remember last year it was a Monday, Wednesday, Friday class, so the classes were all 50 minutes each. And so maybe she's trying to be fair to them because the class is only 50 minutes for them, so you're only gonna get 50 minutes for the test as well. As long as you go at a steady pace, you shouldn't have issues making it through. Just assume it's 50 minutes because that's the worst case scenario. Assume it's 50 minutes, and if you have more, then good for you. But when you're thinking about it, just assume you're only gonna have 50 minutes to work on it, unless she says otherwise. Okay, number 7. This is exactly the same as 5 and 6. 2 steps. First one is rewrite it. And then second step is use the power rule on each term. So this time we're given a big fraction. So the top is 3 minus 4x cubed plus 6x, and the bottom is 2x to the 4th. And so you have to know how fractions work in order to simplify this. So one thing we're able to do with fractions is split them up. So if we have a bunch together on top, we can split it into separate fractions. And all that we do is we just leave the bottom the same. So let me zoom in here. We're taking this fraction and we're going to split it up on this minus and plus sign here. So instead of 3 minus 4x cubed plus 6x to the 5th over 2x to the 4th, we have 3 different fractions: 3 over 2x to the 4th minus 4x cubed over 2x to the 4th plus 6x to the 5th over 2x to the 4th. So everything's divided by the denominator. Okay, and this is what we want because now everything is separated. We have a bunch of separate terms. And then there's one more rule that you need to know for this to work, which is how to deal with powers that are both on top and bottom. So if you remember what we had previously, a power on the bottom, that's the same as a negative power. So for the first one, x fourth on the bottom, that's just x to the minus 4th. But when you have something on top and bottom, you subtract them. So for the second term, it's x cubed over x to the 4th. So you get x to the 3 minus 4, right? So you subtract the power on bottom, x to the 3 minus 4. And 3 minus 4 is minus 1. So that's how I got that. Same for the last term. So we have x to the 5th on top, x to the 4th on bottom. So we're going x to the 5 minus 4, which is x to the 1, or just x. You can just write it as x. Okay, so these are the these are the three terms. We've rewritten it in the right form. Now time for power rule. So first term, x to the minus 4th, that gives us minus 4x to the minus 5th. Second term, x to the minus 1, that gives us minus 1x to the minus 2. Third term, x to the 1, that just gives us 1x to the 0. Or another way you could look at this is if you just have an x like this, then it goes away when you take the derivative. So if I had 3x, then the derivative is just 3. And that might be a simpler way for you to think about it. So if they're by itself, the x goes away. Okay, and then I simplified it, same as before, and we get our final answer. Okay, so each one of these, 5, 6, and 7, they have their own trick. So for 7, the trick was to split up this fraction. For 6, the trick was to FOIL it out. And then for 5, it was pretty straightforward. Okay, but everything is just to get it in this form. Okay, any questions on this one? All right, cool. All right, let's keep going. Sorry, I'm being a little bit slow. We got 3 left. These are important. These are unless you understand the concepts behind them. So number 8 is asking about tangent lines. So I've drawn a picture here. Let's see what a tangent line is. We have this curve, f of x, this red curve. A tangent line is you find a point somewhere on this curve. So it's given by like x naught and y naught. That's the point. And then it has some slope, which is the derivative at that point. So it's f prime at x naught, right? So you have a point and you have a slope. Point on the curve and a slope at that point. And that will give you the equation of the line. We have this thing called point slope form. So all you need to write the equation of the line is the y coordinate, the x coordinate, and the slope. Okay, so we're just trying to find the equation of this line for the function. Okay, so we need 3 things. We need the 2 coordinates and we need the slope. For this problem, it's real simple. They give you the x coordinate to start with. So let's look at number 8. If f of x equals 2x cubed minus 4x squared plus 1, find the equation of the tangent line at x equals 1. So what they do is they give you the x coordinate. Okay, and pretty common sense stuff from here out. In order to find the y coordinate, you just take f of x naught. So you plug in your x coordinate into f, and it will give you your y coordinate. Okay. And the same way, f prime, the derivative is the slope, right? So if you find f prime, and then you plug in your point x naught, that'll give you the slope. So all you're doing is you're taking what they give you, this x naught, and you're plugging it into f and to f prime, and that will give you y naught and m. Okay, so just a bunch of plugging in here. That's all there is to it. Okay, so let's get into it. There's actually not, like, there's a lot of lines here, but there's actually not much work if you know what you're doing. So we're given x equals 1, so that's our x coordinate, x naught equals 1. We're going to find the derivative because we'll need it later. And so the way we do that, it's already in the right format. So all we do is just use the power rule. So the first term gives us 6x squared. The second term gives us minus 8x, just using the power rule on f. Okay, and I didn't show any extra work here, not necessary. Now we have the derivative, we have f. So let's start by finding the y coordinate. So all we do to find the y coordinate, y naught, is we just plug in x naught into f. So we have 2 times 1 cubed minus 4 times 1 cubed plus 1, and that's minus 1. Okay, so y naught is minus 1. Second step, plug x naught into the derivative this time. So the slope m at that point is f prime at x naught. So that's this, 6 times 1 squared minus 8 times 1. And that gives you minus. So just plug in x naught into both and you'll get y naught and m. And then all we have to do is remember this formula. So y minus y naught equals mx minus x naught. Plug those in and we get y plus 1 equals minus 2 x minus 1. Be careful with these minus signs here. So our y naught was minus 1. So when we do y minus y naught, we get y plus 1. All right, so minus and negative is positive. So just make sure you don't get those mixed up. Okay, any questions on 8? Just two major steps here. Just plug into the f and the f prime. All right, cool. I can come back to this later. All right, number 9. Number 9 is even easier. Very simple ideas here. So if we look at this picture that I've drawn, we have some function, f of x, this red curve, and we want to know where the tangent line is horizontal. So you got to know that these all mean the same thing. The tangent line is horizontal. That's the same as the slope being 0, like it's flat, which is also the same as derivative. So f prime equals 0. So these all mean the exact same thing. Here, I'm going to scroll back up to number 8 real quick. Is there anything you missed? Okay. Oh, sorry, I got a question on this one. Why would it be y plus 1? So we have, looking back at number 8, we have y minus y naught. And so for us, that's going to be y minus negative 1. Okay, and then minus a minus 1 gives us a plus 1. So that's why we have y plus 1. All right, cool. All right, so anyway, number 9, very simple idea. Tangent line is horizontal. That just means the derivative is 0. So all you have to do is set the derivative equal to 0 and solve for x. Just that. Okay, so they give us this 2x cubed plus 3x squared minus 12x plus 2. They want to know where the tangent line is horizontal. So first step is to take the derivative. So power rule, 2x cubed, that's just 6x squared. The second term gives us 6x, and the third term gives us 12, minus 12. Then the last term is a constant, so it's 0. It goes away. So I can just write that as plus 0. Okay, so just the power rule to get the derivative. Next step, very easy. Set the derivative equal to 0 and solve for your x. So this is my derivative, 6x squared plus 6x 12. Set that equal to 0. And now you just do some algebra. So the steps I took here, first I divided by 6. I divide everything by 6 on left and right. 0 divided by 6, that's still 0, so nothing changes. 6x squared, the 6 goes away, the 6 goes away, and then on the last one I'm left with 2. So all that did was just clean it up. Now it's simpler to look at. And from here, you can use the quadratic formula if you want, or you could factor it. So to factor it, I need, let's see, the two numbers need to multiply to get minus 2, and they need to add to get 1. So the way you do that is with 2 and minus 1. Okay. And so those are my two factors. And the way I make these equal to 0 is by the opposite choice. So for x equals minus 2, this term will be 0. And then for x equals positive 1, this will be 0. So that's my answers. And this is one of those problems where she wants you to write it in a specific way. So for this one, it's just writing it out more or less like a sentence. So we say f of x has horizontal tangents at what we just found, x equals -2 and x equals 1. And that's the format that she has her answers in. Horizontal tangent at x equals 1 and x equals -2. Yep. Okay, so this one's real simple. Set the derivative to 0, period. Okay, any questions on one more? Just one more. Thank you all for hanging on. And then after that, you can ask me whatever extra questions you have. All right, number 10. This one is the most economical out of all of them because we actually are dealing with money now. The price-demand equation. So number 10, the price-demand equation for a company that produces X umbrellas per week is given by P equals 25 minus 0.01X. Okay, so keywords here, price-demand equation, X umbrellas per week. So X is the amount of things that you're selling each week. Okay, and then we're given this equation P. This is your price. This is the price they're going to charge per umbrella. And let me just do a quick explanation here. So this price depends on X. It depends on the number of things that you're selling. So if the company can only sell one, X equals 1 umbrella per week, price is this. 25 minus, that's 1 cent times 1. So it's $24.99 per umbrella. So if they only sell one a week, this is the price. If they can sell 500 umbrellas in a week, then the price is, $25 minus 500 cents. So that's $5 off. So we get $20 per umbrella. So the more they're able to sell, the less they will charge per each one. Okay, and that's why this is structured this way. All right, part A. Find the revenue function and then evaluate it at X equals 1,000. So this is X equals 1,000 umbrellas per week. So the revenue, very simple. This is the incoming money. This is the money that you're making. So the revenue, that's just the price of each item, which we have, that's P, times the amount that you've sold, that's X. So if I sell, so like in this example here, they're $20 each and I've sold 500 of them, okay? So that's $10,000 or something. Okay, so R of X equals PX times X. That's what you need to remember. R of X, revenue is price times X. Okay, and so if we work that out for this problem, R of X equals X, so we write in our P. So this X in parentheses here, that just means it's a function of X. I'm not multiplying it here. So this just means, so when we expand it, this is our price, 25 minus 0.01X, and then we multiply by X. And so all we've done is just raise the power on each term. So we have 25X minus 0.01X squared. And that's the revenue. Very, very simple. That's one of your answers. It's one of the answers. So you want to box that. Step 2 is evaluated at X equals 1,000. So all that means is you take it 1,000 umbrellas per week, X equals 1,000, and you put it in here to see what your revenue is. So R of 1,000 is 25 times 1,000 minus 0.01 times 1,000 squared. So this works out to 25,000 minus 10,000, which is 15,000. $15,000 per week, that's your revenue. The units here, like dollars and per week, those aren't necessary, but that's just what it means. So the revenue is going to be some amount of dollars per week in this case. And then that's it. That's the answers. So you have the revenue function and the revenue function evaluated at 1,000. I just have an extra explanation down here if you want to read that. Okay. Part B, marginal revenue. So we had revenue, now we have marginal revenue. All that marginal means is we take a derivative. So we had before r of x. So to get the marginal revenue, we just take r prime of x. So the derivative of r. And after that, it's just the same process. You take r prime, and then you plug in 1,000 and see what you get. Now, the actual definition of marginal is kind of confusing. So, but you're going to need to understand it in order to answer this question. So, the way I understand it, marginal revenue is the change in revenue after we've sold some number of units. So, it's the change in revenue that each extra unit gives us. So, for example, the marginal revenue at 300 will tell us the additional revenue earned on the 301st unit. So if I've already sold 300 and I sell one more, how much did my revenue change? That's what the marginal tells us. And you're going to need to know that for your answer. So like I said, marginal revenue, that's just a derivative. So r prime of x, we take what we had before, 25x. Power rule makes that just 25. Before we had minus 0.01x squared. So the 2 comes down and then we reduce the power by 1. So this gives us minus 0.02x. Okay, so just took the derivative, power rule. This is our marginal revenue function. Now it wants us to plug in. So evaluated x equals 1,000. So we stick in 1,000, work it out. We get 25 minus 20. That's $5 per umbrella. So what that means is after we've sold 1,000 umbrellas, then the next umbrella we sell will increase our revenue by $5. Okay, and so looking at the question, there are 3 parts: find the function, evaluate it, and then interpret it. Okay. So we found the function, we evaluated it at 1,000, we got $5. And then the explanation is worth a lot of points. So it's very important that you get this correct. There are 2 ways that you can say it. The way this really works is that each umbrella that we sell increases the revenue, right? With diminishing returns. The way that we say this is one of 2 ways. The first way is to say production level 1,000. The revenue is increasing by $5 per umbrella. Okay, so this is the production level way to say it. So once we are producing 1,000, the revenue increases by 5 per umbrella. That's one way to say it. The other way is to say, like I said it before, the revenue earned on the 1,001st umbrella is $5. So you can talk about this specific umbrella. So the next one you sell will earn you an additional $5 in revenue. So that's the other way to say it. Oh, and then I had one here, which is, how did I get this 0.02? That comes from the power rule. So if we look at r of x, it has this term minus 0.01x squared. So doing the power rule on that, we take the 2 and we multiply by it. So 0.01 becomes 0.02 from the power rule. And then we drop the power by 1. Of x squared, we have x. Okay, hopefully that answers y'all's questions. All right, so that's the entirety of it. That's all 10 questions in every part of each of them. So if y'all have any questions now, go ahead. You're welcome. You're welcome. Quiz 4 is due. I'm not sure when quiz 4 is due actually, but it's not for a while. Okay, I'll look into that, but don't worry about it too much. Yeah, this is due 11:45 tonight for 2 bonus points on your test. But yeah, that's it. So are there any other questions about like specific problems that you have? You're welcome. You're welcome. I hope that was helpful.
Thank you so much.
You're
Yeah,
welcome.
thank you.
Y'all have a good night.
Thank you.
You're welcome.
Thank you.
Thank you so much.
So
Your
helpful.
goat.
You're welcome. Thanks.
Thank you.
Nice. All right, y'all. Y'all have a good one to everyone who's leaving.
Thank you. Appreciate that.
You're welcome. See ya. Okay.
And we just need to email you to get this sheet.
Yes. So just send me an email and I'll give this to you as a PDF.
Awesome. Thank you so much.
You're welcome. Thanks for coming.
I have a quick question.
Yes.
You said the test will be similar to this practice.
Yeah. So the test is usually very similar. So like this breakdown I have. So question 1 about limits, question 2 about the limit definition, question 3 about discontinuity points and asymptotes. They're usually going to be in the same order. Sometimes they're even just like renumberings of the same problem. Sometimes they're that similar. But
Thank you.
let me qualify that real quick so you don't get too happy. So if we have something like on 4, 5, and 6 especially, like the trick that you use for this one might be different. The trick that you use for 7 might be different. So instead of splitting up the fraction, it might be something else. And then one other important thing, if we look at say like number 8, when they give you this function, it starts out in the right form. Like you don't have to rewrite it at all. It's already correct. But she might give it to you as something like x plus 3 squared, which means you have to rewrite it first and then take the power rule to get the derivative. So there might be extra steps, there might be less steps, but usually they're very similar.
Thank you.
You're welcome. Thanks for coming. All right, here, let me check.
I might.
Thank you. You're welcome. All right. So would anyone like me to work through an example? Are you good?
Could I ask you a question that I've been wondering from the quizzes?
Of course.
When I get a number and like in terms of dollars and it's like a decimal and something like 0.4, 0.5.
Oh yeah.
Would that be like 40 cents? Or like when I'm supposed to like write it out, would I write it as like it's increasing or decreasing or whatever by 40 cents or like $0.4 or?
Yeah, so as long as they're equivalent, it works. Just make sure you don't get the units mixed up. So make sure you don't accidentally write points, right? So $0.4, 40 cents, those mean the same thing. So either one is good.
So when it's a decimal and then the number, it's just like, okay, yeah.
Yeah, so
thank you.
Yeah, you're welcome. All right. Aline, do you have any questions?
Yeah, I was wondering if you could go over number 9 on the quiz, or quiz number 3, because I was a little bit confused on that one.
Oh yeah, sure. Let me pull that up. I don't know if I have it here. So give me 1 second. Okay. Quiz number 3. Okay.
Number 9.
Wait, you say quiz number 9? Oh, sorry, quiz number 3.
No, quiz number 3, question 9. Sorry.
Okay. I'm like, wow, you're really far ahead. Okay, so this says evaluate the marginal revenue at x equals 80. Wait, can you read yours out for me?
Yeah, it says evaluate the marginal average revenue at x equals 80.
Oh, okay, so this one's slightly different. So instead of marginal revenue, it's marginal average revenue. And so all average means is that you divide by x. So you divide by the number of things that you've sold to get the average one. So let me make sure I have that correct. Let's see. So you get the revenue, which is just price times x, which I already discussed, right? The marginal revenue is the derivative of that, so that's r prime. Let me just give you the formulas. average revenue is you divide by X, and then marginal average is you divide the marginal by X. So let me make sure that's correct. R prime of X equals minus 0.2. Right. Sorry, I just want to make sure I'm not misleading you. Let me give you the right answer here. R prime of X, so it should be minus 0.2. So have you gotten all of them up through number 9?
Yeah, I was just confused because I think we like take the derivative of the average revenue function, but then like my formula didn't have X in it. So like on number 9, when it said like evaluate it at X equals 80, I wasn't sure like what I was supposed to do.
Oh, okay. So this makes sense now. It's all coming back. Let me write it. Let me write it down here. So let me share. Okay, so let me stop the recording. Or no, I'll let it keep going in case someone else has a question too. So for this one, let me fix this. Okay, so there are 4 formulas here. So revenue, R of X equals price times X. All right, so we know that one. And then marginal revenue, that's R prime. That's just the derivative of the revenue. So this is revenue. This is marginal revenue. That's just the derivative. And then you have, it's really just like a copy of these. Average revenue is revenue divided by X. So it's the average per item sold. And then to get the marginal average, you just take the derivative of this. So actually this is written R with a bar on top. So this is the way you write average revenue. It's R with a bar on top. And the marginal is just the derivative of that. So that's R bar prime. Okay, so you said that your average revenue did not have an X in it?
No, the marginal average revenue.
Oh, the marginal average.
Like I just, yeah, like I just got a number.
Oh yeah, if you just got a number, that's totally fine. That's totally fine. Yeah. So yeah. So actually, that's correct. So for this one, it should be just a number when you get down to the marginal average. But this is the way that you found it, right? The derivative of the average.
Yeah.
Okay. Yeah. So yeah, this is how you do it. And it's fine for it to be just a normal no X's constant.
So
Sorry
then for number 9.
Sorry?
No, it's okay. So then for number 9, when it says to like evaluate it at X equals 80, do we just leave it as
I'm
the
sorry.
number?
I think I just understood your question. Yeah. So yeah, when you don't have an X to plug into. So
Yeah.
Yeah. Okay. Sorry that took me so long.
No, it's okay.
So if I have something like f of X equals 5, then it doesn't matter what I put in. So if I put in f of 80, I still get 5. And so what this actually looks like if you picture this function, f of X equals 5, then it's just a horizontal line at 5. So it's always 5, no matter what you put in. It's 5. So whatever number you have, if you plug in whatever marginal average you came up with, if it doesn't have an X in it, then the 80 doesn't matter. It's always the same number. So it'll just be whatever number you got. So
Okay.
does that
makes
make sense?
Yeah.
Okay, good.
Makes
Yeah. So if you don't have a place to plug in an X, you don't have to plug in an X. So that's just the answer. Plug in an 80, nothing changes. You still get 5 for this one.
Okay, that makes sense. Thank you.
You're welcome. Is that all?
So for tomorrow for the test, like we print it out and then do we immediately log into Zoom or do we have to wait till like our class time starts?
You're given access to it early, right? Like to
I
print it
think
out.
I think
Uh,
10 minutes. is
Yeah,
what
yeah. So
they-
that's
she
just
said
for
in
you
the
to like
video.
that's for you to print it out and have it ready. So you won't start until the class time starts.
Okay.
But you can log into Zoom early, and she'll be giving you instructions on what to do, even before the starting time. So yeah, just get it printed out and then wait for her to tell you to start.
Okay. Sounds good. Thank you so much for your help. Have a great rest of your night.
You got it. Good luck tomorrow.